Assalamualaikum warahmatullahi wabarakatuh. So for the introduction, chili is a warm season crop showing sensitivity traits to ambiotic and biotic influence. A well-drained, moisture retaining loamy soil is said to be ideal for chili development and output. And then many variables influence pepper output, and the most significant restrictions are related to water or nutrient deficit. Lastly, in order to boost agricultural yields, a great deal of chemical fertilizer are added to soil, which has a significant negative effect on the environment. Yes, so the problem statement, the fuzzy logic method, which is based on a probabilistic approach, is now the most often used strategy. Students' evaluation of their own performance serve as the basis for using this approach, which combine the fuzzy logic approach with another. It is difficult using the conventional technique to determine which students have a high level of academic achievement and whose parents have a modest income. As a result, a fuzzy set theory based on a fuzzy logic is suggested in this study. The suggested strategy is anticipated to provide higher classification accuracy than the traditional approach. So we have two objectives, which is to evaluate the chili growth by using the fuzzy inference system (FIS) in MATLAB software. Second objective is to propose a fuzzy logic to finding the best chili production and the worst environment for chili crops. For the scope of study, the purpose of this project is to develop a plan of chili through the adoption of best practices in production by using a fuzzy logic technique. There are many datasets can be used, but for this project, the dataset that will be used are the appropriate temperature and amount of water. Okay, for the literature review, we have four literature review. So for the first one is according to Kalagiru 2014, inference is a method that analyzes the values in the input vectors and assign values to the output vectors based on certain sets of rules. In fuzzy logic, the truth of any assertion becomes a matter of degree. A fuzzy inference system is used in many fields, including formatting order. So last one, the fuzzy inference system is made up of four major components. So for the second one, using the fuzzy rules base, a multi-output system is divided into a number of single output systems. Because the if-then rule is so wide, it may be applied with almost any rule, from Abdul Wahi 2011. And last one, the fuzziness rule base will subsequently be used by the fuzzy inference engine, which is the main component of the inference system. Okay, so for the third one, literature review is a fuzzifier is a machine that maps a real value point x to a fuzzy set y from a collection of sensors to value between 0 and 1. According to ACMA, the fuzzifier must meet the criteria plausibility, computationally stability, and continuity. Fuzzifier are classified into three types: singleton fuzzifier, Gaussian fuzzifier, and triangular fuzzifier. Noise corrupt the input in order to reduce noise and the fuzzy inference engine computation and streamline. So for the last one, the literature review is a fuzzifier is a machine that maps a real value point x to a fuzzy set y from a collection of sensors to values. According to Ta 2016, the stage at which the capsicanoid begins to accumulate should not be species specific, but rather dependent on cultivation conditions such as temperature, the period of light exposure, and fertilization. In addition to climatic factors, other factors such as geographic location, growing and processing condition, and stage of maturity also influence the capsaicin content. And the last one, according to the fuzzy logic, using fuzzy logic to assess the plan of chili is thus not only theoretically supported, but may also be an important element of the decision making and evaluation processes of farming institutes. Okay, for the first step of the methodology is identify the inputs and output. Second, construct the membership function. Third, construct fuzzy rule base. Fourth, fuzzy cation. Fifth, inference engine, and the last one is the fuzzification. There is four components in fuzzy system. For the first one is fuzzifier. Fuzzifier has four types, which is singleton fuzzifier, Gaussian fuzzifier, triangular fuzzifier, trapezoidal fuzzifier. The second one is fuzzy rule based. Have four types also. First one is partial if then rule or rule, single fuzzy statement, gradual rule. So the third one is fuzzy inference engine. Have two types, composition based inference and individual rule based inference. So the last one is the fuzzifier. Have four types. Centroid method, center of gravity method, Gaussian falsifier. Second, weights average method. The third one, maximum membership principle, height method. So the last one is min max membership principle, middle of maxima.
Okay, Assalamualaikum and hi. My name is Mirza Akmal Hakim bin Muhammad Rizal, and I'm going to present about MATLAB tools for solving FIS, which is fuzzy inference system. Okay. For the step one is identify the inputs and outputs linguistic variables, the linguistic value and range. Okay. For the linguistic variables, we have input which is two input which is temperature and water, which temperature have linguistic value for low, medium, high, and water linguistic variable have little, enough, and a lot. Okay, for the range of the linguistic variables temperature and water, range for temperature we have 20 to 37, and range for water we have 0.5 to 2. Okay, for the output, the linguistic variable is quality chilies, and the linguistic value is poor, medium, good. For the range is from 0 to 100. Okay, for the step 2, which construct the membership function for each input and output linguistic variable. The first one is the membership function for the temperature is given as following. We can get a membership function temperature low, which the range is from 20 to 28. The first one is 20 to 24, which we can get x minus 20 over 4. And the second one is 24 to 28. We can get 28 minus x over 4. Elsewhere, we can get 0. Okay, for the membership function temperature medium from 24 to 28, the formula is x minus 24 over 4. For the 28 to 32, we can get the formula is 32 minus x over 4. Elsewhere is 0. For the last one is membership function temperature high from 28 to 32. We can get x minus 28 over 4, but the 32 until 37, we can get the formula 37 minus x over 5. Elsewhere is 0. Okay, for the next membership function for the water, the range of this membership function is 0.5 till 2.0. The first membership function, water litten, the range of 0.5 until 1.3. We can get the first formula is y minus 0.5 over 0.3 for the 0.5 until 0.8. And the next one is 1.3 minus y over 0.5 for the 0.8 until 1.3. Elsewhere is 0. Okay, for the next one, membership function enough, we can get y minus 0.8 over 0.5 for the 0.8 until 1.3. The next one is 1.5 minus y over 0.2 for the 1.3 until 1.5. Elsewhere is 0. For the membership function water a lot, we can get y minus 1.3 over 0.5 for the 1.3 until 1.8, and 1.8 minus y over 0.2 for the 1.8 until 2.0, and elsewhere is 0. Okay, for the third membership function is for the quality chili. The range of this membership function is 0 until 100. The first membership function is quality chili poor. The range for the 0 until 40. We can get the first formula from 0 until 20, which is z over 20. And the second one is 40 minus z over 20 for the 20 until 40. Elsewhere is 0. Okay, for the next one is membership function of quality chili medium. We can get z minus 30 over 20 for the range 30 until 50. And the second one is 70 minus z over 20 for the range 50 until 70. The third one is membership function of quality chili good. Z minus 60 over 20 is the formula for the 60 until 80, and 80 until 100 will have formula of 100 minus z over 20. Elsewhere is 0. Okay, for the step 3, which is construct knowledge based on rule. The table shown is the fuzzy if then rules of this study. The first rule, if temperature is low and water is little, then chili production is poor. For the second rule, if the temperature is low and water is enough, then chili production is medium. The third rule, if the temperature is low and water is a lot, then chili production is good. Fourth rule is if the temperature is medium and water is a little, then chili production is medium. If the temperature is medium and water is enough, then chili production is good for the fifth rules. And the sixth rule, if the temperature is medium and water is a lot, then chili production is good. For the seven rules, if the temperature is high and water is a little, then chili production is poor. The eighth rules, if the temperature is high and water is enough, then chili production is poor. Okay, for the last rules, which is nine rules, if temperature is high and water is a lot, then chili production is medium. Okay, for the step 4, which is convert crisp data into fuzzy data sets using membership function. During the fuzzification process, numeric input variables are converted into the corresponding fuzzy sets via membership function. For example, the membership value for temperature in fuzzy set law is given as membership function NC numeric 26 equal to 28 minus 26 over 4 equal to 0.5, whereas the membership value for the temperature x equal to 26 in fuzzy set medium as uh, membership function numeric 26 equal to 26 minus 24 over 4, we can get 0.5 also. Okay, for the step 5, which is evaluate rules in the rule base and combine results from each rule. When we let x equal to 26 and y equal to 1.8, we can get a membership function of temperature medium 0.5, and also for membership function of water a lot, and membership function of quality chili good for membership function temperature medium. For the next one is membership function of temperature low. We can get 0.5 for membership function of water a lot. Uh, and the next one is membership function of quality chili good. And for the next figure is the membership function of the result for the first figure. Okay, for step 6, which is convert output data into non-fuzzy values. For the membership function quality chili z equal to z minus 60 over 10 from 60 until 70, and we can get 1 from 70 until 90, and 100 minus z over 10 for 90 to 100. Okay, for the next one is formula and step for calculation. Z equal to integration z quality membership function quality chili multiply z over integrate quality membership function quality chili, and we can get 80% from the calculation.
Hi, my name is Afif Daniel. So I want to present our step 7. There's a 5 editor use fuzzy interface system by MATLAB. So its function to design fuzzy system logic, display general information about fuzzy interference system. So as you can see in our first picture, temperature is our first input and water is our second input and quality chili is our output. So number 2 is our membership function plot, our temperature, first input. And the second one is water, our second input. And lastly is our output, is quality chili. Hi, okay, next number 3 is rule editor next decide on connection for variable such as and or and define all the rules for the fuzzy inference system. Next, number 4, rule viewer. If you put the value in all input variable, this editor give the result for the output variable. And number 5 is surface viewer. Generate 3D surface from input variable, which is the temperature and water, while output is variable for quality GDs. Okay, next is result and finding. The output variable, which is selection of interview candidate who are applying for job, can be defined using first one is weighted average method. So that's a formula where summation denote the algebraic sum y is the center of its symmetric membership function. So the result is 20. The second one is maximum membership function principle or known as a head method. So that's a formula. So it's limited to be a peak output function. For example, the max membership value based on the figure 6, the max membership value is 1.5. So number 3 is main max membership principle or known as the middle of maxima, as the minimum membership value is not unique as a compared to the maximum membership principle. So that's a formula where y1 and y2 are the lowest and upper value of the interval containing maximum membership value respectively based on the finger 1. So there's a formula y1 is 10 and y2 is 30. So divide 10 plus 30 and divide by 2 is 20. Okay, next is inference process. The selection of interview candidate who are applying for job is shown in table with respect to the input value of the input variable. So we have a 5 candidate, interview candidate, and our input variable temperature and water, and output variable is quality CD. Okay, next is corresponding inference process of 3 different input value for the input variable, which is a temperature and water. So in our first picture is let's say the temperature is 26 and water is 0.8. So the quality of chili is 80%. And then second next is the temperature is 26.3 and the water is 1.1. So the quality is 52.7. Okay, next. The temperature is 26.5 and water is 1.19. Then quality chili is 58.1%. And the fourth is temperature is 27.5 and water is 2. So the quality chili is 50%. And lastly, our candidate is temperature 28 and water is 1.4. And the quality chili is 75.5%. Okay, our conclusion is the FAS model, which is based on the project, is very helpful in determining and evaluation of the project's performance. Next, by using this in a conjunction with sound reasoning, it is able to quantitatively assess the state of ongoing activities and the challenge they are provided through the visualization. And lastly is, any process may be mechanized much more easily when employing a fuzzy inference system.